Well, good morning, class. I'm not there in class, but you still can't get away from me. So, anyways, I am in some training this morning. I figured I'd make a video to go over just a few things before you take your quiz today. We have finished section 4.1 and 4.2, so we are ready to move now into section 4.3 to talk about some more trigonometry concepts. First, I thought I'd start off with a little fun riddle here. I'd like to know if anybody could tell me what 1 over n times the sine of x is. Well, the answer is 6. One times 6 is 6. Okay, yeah, hopefully some of you are laughing, but anyways, that is just a silly joke, right? We've seen that sine of something is a complete quantity and we can't break it up. But anyways, now what I want us to do is I'm going to start at the unit circle. I want us to talk about this 16-point unit circle. Your quiz today is going to be you taking this blank template here and putting the angle measurements that each one of these lines represents. And we start off by saying, okay, we kind of know, it should be known, we're starting off with this known fact that 180 degrees is pi radians. We established why that is so when we first started trigonometry. It has to do with the fact that the circumference of a circle is 2 pi r, or pi times d. And we know that all circles in the universe, when you take their circumference divided by diameter, you get this constant called pi. So that led us to this true equality right here. So that being the case, since this is 180 degrees, we are going to call this then 180, and we're going to call it pi radians. Now, I did want to backtrack just a bit here. This whole discussion that we're having on the unit circle is predicated on the fact that it's setting on an xy plane. And so we can really think of this as being the origin right here of the xy plane. And when we talk about angle measurements on the xy plane, what we're doing is we're saying, okay, we're going to start with an angle of 0 along the x-axis. So in a sense, what we're really saying is we start with an arrow resting on the positive x-axis, and then it's going to begin rotating counterclockwise. Anything that rotates upward is a positive angle. And so if I rotate this red arrow in this direction and it ends up right here, then this arrow is representing a 90-degree angle. Okay, now if I rotate down this way, those are still angles, but they have a negative measurement. Now remember, these angles are always caused by rotation. And so we are considering the fact that the angle is created by the arrow sitting on the positive x-axis. So if this arrow rotates down this far and stops, then that angle, this angle right here, is what we call minus, well, not 90, that one would be 45, wouldn't it? So that would be a negative 45 degrees. Okay, so that's the first thing to understand about positive and negative angles. All right, we'll scoot down here. I want to put another unit circle up for us. See if this works. There we go. Okay, so let's talk about what we call coterminal angles. Now, what you want to do, class, in your textbook, you want to go in and read what coterminal angles are. This is one of the things, one of the terms that you have to know and be able to define. But coterminal angles basically are angles where the rotation away from the x-axis ends up at the same spot along the unit circle. And what I mean by that is we're saying that this is going to be the initial side of my angle. It's always resting on the positive x-axis. If I decide to rotate 135 degrees, positive 135 degrees is rotating 90 and then another 45. And so basically what I've got is I have this angle created. It has an initial side and it has a terminal side. Okay, and we know that that is 135 degrees, positive 135 degrees rotation, because on our unit circle we've got 135 degrees over here. And that is an angle. It has to have an initial side and a terminal side, because I have to know how to, I have to have two sides between which to measure the rotation. Now let's suppose that what I want to do is I want to do a rotation of minus 225 degrees. So I will start with my initial side here. I will rotate 90. I'll come over here 180. Another 45 takes me to 225. Now, since it's negative, I'm rotating in the negative direction. And so when I do the minus 225 rotation, I end up on the same line as my positive 135 degree angle. In fact, if you simply look at the terminal and initial sides of those two angles, you can't differentiate them. They look the same. They both have their initial side here on the positive x-axis, as all angles in the xy plane do, but they both end up lying on the same line here on the unit circle. And so unless you saw me do the rotation, right, if I get rid of the fact that I did this rotation, you would not be able to tell which one was 135 and which one was negative 225, because they basically look the same. And those are what we call coterminal angles. So we can say that a positive 135 degrees and negative 225 degrees are coterminal angles. And that probably doesn't surprise you, because coterminal means they share or have in common the same terminal side of their angle. So that's the first definition that we need to understand, coterminal angles. And you'll notice one of the things that makes those two coterminal angles is that if I take 135 degrees and I subtract 360 degrees from it, I am going to get negative 225 degrees. Or conversely, if I take negative 225 degrees and I add 360, it puts me at 135. So coterminal angles basically, as you can see, are found by adding or subtracting multiples of 360 or multiples of 2 pi. That's how I get coterminal angles. In fact, we could come up with really an infinite number of coterminal angles to these two, the 135 and negative 225, because if I take this the green side here, this 135 degree angle, and I do another 360 degree rotation, it's going to end up, the terminal side will end up on the same line. And so unless you saw the rotation occur, you would not be able to differentiate which was the 135 degree angle and which was the 135 plus 360 degrees angle. And when we add those together, we get 495. So we can say that 495 and 135 and negative 225. They're all coterminal. So there's an infinite number of coterminal angles to any angle that you select. You just simply rotate multiples of 360. You've got yourself a coterminal angle. Okay, nothing too complicated about that. All right, so let's do an example. I'd like you to try to work this in your notes. Suppose I give you an angle of 2 pi over 3 radians. And I want you to find two coterminal angles. And I want one to be positive, and I want one to be negative. Okay, so what we can do here is we'll pause at this point. So maybe our substitute or one of our students can pause this, and I'll give you a few minutes to come up with your answers. All right, let's see what our solution is here. So 2 pi over 3. So what I'm going to do to find my positive coterminal is I'm going to add one rotation. Right, that's basically what we're doing. We're adding one rotation, which is to add 2 pi radians. Well, if I'm going to add those, I have to get a common denominator. So 2 pi over 3, I'm going to have to get a common denominator of 3, so it becomes 6 pi over 3, which is 8 pi over 3 radians. That is a coterminal angle to 2 pi over 3. If I subtract 2 pi, so now I'm going to have 2 pi over 3, I'm going to subtract 2 pi, or take away 6 pi over 3. I then get negative 4 pi over 3. So those are my three coterminal angles. I have 2 pi over 3, 8 pi over 3, and then negative 4 pi over 3. Those are all coterminal angles. Okay, I think what we'll do is we'll end the video here, and then I'll start a new one. So pause this one or stop this, and then start the next one.